Hey, Bo.
Hey, morning, guys.
Good
Good
morning.
morning.
Or maybe
What's
it's yeah,
that?
midday for you guys then.
Yeah, it is just a
Oh,
little.
you're out in Washington?
Yes.
Yeah.
Yeah, I used to live in Vancouver for 8 years, Vancouver,
Oh,
Washington. Yeah.
oh, nice. Good deal.
I made it out to the eastern side of the state once in a while, so
Oh, yep.
yeah.
Dry side, huh?
I was a Syngenta rep out there for a number of years.
Okay. Nice. How long ago was that?
I left there in 2014,
Okay.
so uh, became quite familiar with the specialty ag marketplace in the Pacific Northwest.
Oh, yep.
British Columbia, all the way down into Northern California, actually, was my whole territory.
Oh, wow.
So
Nice.
didn't do a lot with grains, small grains, or any of the Syngenta fungicides or any of that kind of stuff, but mostly specialty crops.
Oh, yep.
Yeah.
Okay. Good deal.
So I've got your reports here. Joe, you want me to just share and start?
Yeah. Yeah. Go ahead.
See my screen there?
Yep.
Okay. So what I was looking at was the Haney
Uh,
test.
I'm not seeing your screen yet.
You're not?
Uh-oh.
I
Uh-oh.
can see it.
Huh. Well, hold on. Let me look over here. Yeah, I got it. I got it.
So well, Bo, this is great. I'm glad you did these total nutrients, the Haney's, and I got one B crop report,
Okay.
but this gives me a lot to look at.
Now,
So,
yeah, this is the first year I took these Haney's and total nutrient digestion, and I'd say it's an eye opener.
right.
I'd almost say it's something everybody should have a few of them that farm.
Oh yeah, I think so too, because what we're ultimately going to build up over time is the total nutrients. So,
Yes.
the way the function works is it goes from available nutrient to a total. So what I like about what this total nutrient offers is, this is a 0 to 6 inch depth, so you could actually go up another 20% of total when you look at it 0 to 8. Uh,
Oh,
so you'll see a number that's quite astounding. But that's the really eye opening piece of it is when you look at the equivalent fertilizer value for what the total is, and that's astounding, isn't it? When you look at that.
yes.
So these all run within the same. Are they all within us? Geographically pretty close together, because I was looking at these as we're looking at 1700.
Yes, they're all within a 5 mile radius on the
Okay.
farm. And so these samples that I took here, eight are I've been doing the B crop samples for I got 3 years on them, and so this last year I finally did took the total nutrient and Haney off those same samples. So yeah, so that's where I had picked 8 fields 3 years ago to run with, and this last year was the first year I did these other extra samples.
That's great. Because it kind of gives you a base where to start, and you can start looking at how we're going to be able to look at this from a digestive point of view instead of just a total, available nutrient level. So I'm just going to start with this first one here. Thing gets right in my way. Zoom has this little bar at the top that makes it so hard to see things. Okay, here we go. So I was highlighting these a little bit, and I was going to ask some questions here. When I
Yep.
look at these available levels of P and K, so are you applying manure here, or what's the?
Yes. So my farm has I'd say a long history of feedlot manure. It's not every year, but yes. So this field here is within 1 mile of a 10,000 yard feed yard. So, so I would say it has 30 to 50 years of manure history. I would being that it's been that close, that it's had potential to have manure on it. So
if you recall, our total levels of P were around 1,700 pounds. But when you look at your available P, this is the only source of P you're putting out, right? You're not applying any other material. Good.
The last couple of years, no, I've never. I'd say I've basically never used dry P and K. So basically, on my whole farm with alfalfa, hay, corn, I've been using manure for my potassium and phosphorus.
Well, it really shows up on the Haney. So what I like about this is readily available nutrients. I mean, these are soluble nutrients that are there now. So you can see the levels are very, very nice. I mean, over 100 pounds on every one of these, 120, 130, some over 200. And so that means you have available forms of phosphate. You just need a digestible. You need something in there to digest them, so they just don't build up over time and become unused. And the same is true for potassium. So what I like to do when we're looking at parts per million, you may already know this, is just to double that parts per million to give you pounds per acre, roughly.
Oh, yep.
So that's roughly, in this case, it's 250 plus. Here's a 400. I mean, you got plenty of P and plenty of K, both in all of these. 170.
Yeah, I believe with the manure program, I'm putting on more manure through phosphorus than I'm removing, even with alfalfa hay or a silage corn or any of that, potatoes that have been on the crop. But so yeah, my manure, I've been really applying my manure on a potassium basis, trying to match up with my removal from alfalfa hay. That's how it's been for the last 20 years. That's kind of how I've been managing my manure program. Just basically just off the potassium.
And your potassium levels are double as high, and your total is double as high as your K. I mean your P.
Oh, yep.
Almost in all of these, you're looking at 44. So when it comes to P and K, you're set.
Yes.
Yeah. Very good. There's guys in this area where I'm at would die to have levels of P that high. But the challenge is what we're getting ready to talk about now. When we look at nitrogen, and you're supplementing that every year, right?
Yes, basically nitrogen, sulfur. But I would say the last couple of years I've went to a foliar program, majority foliar, and like I say, I've cut my nitrogen back by probably I'd say 80%. So I went from on grain corn from applying 250 to up to 350 pounds nitrogen, and I've gone to probably 20 to 40 pounds the last 2 years. And what's surprised me is my crops have been maintaining average yields, and my soils are on the standard soil tests are not changing.
Yeah.
On a standard Malick test, my nitrogen levels are basically whole with the organic matter percentage and ammonium levels. They're basically pretty stable, even though I could say I should be mining it all. And so it's kind of one of those baffling deals when I look at that on a standard soil test, how it's even though I've cut nitrogen back way back. So like this field here, 104, or no, the one that was at the top.
This one here.
Or is that the very?
Oh, no, it's the very top. Very top. You want to highlight it? Yeah.
Yeah, that one I've got 3 years of foliar nitrogen, majority foliar nitrogen on. So and with 3 years of corn on corn, and I think the first year I was I think I was 25 pounds applied nitrogen, and then the second year I did silage corn, and that was 40 pounds applied, and then last year was 22 pounds applied on this field.
Yeah.
And so it's and it kind of amazes me. And I did do a 20, no, not sure, I think it was 10 or 20 ton top dress dry feedlot manure on this. So I did a strip till, a top dress manure, and then strip till. So all the manure is left on the surface. I did not incorporate anything. So, but it's still amazing me what these crops are producing without with very little just inputs.
And so what's happening here, and I can tell you what can really drive this number to go up is going to be on this area I got highlighted here.
Yeah.
So I'm not, you're fine with nutrients. I like to see this number when we're looking at a Haney. So the difference between a Haney and a traditional, and you're probably not doing out there, you're probably not doing Malic 3s or doing sat paste. Are you? What lab were you using before?
It's a local lab next to me. So
Moses Lake or?
Yes, Moses Lake, best test. So
yeah. So did they do, does Moses Lake do Malics?
Yes, yeah, it's okay. A standard one is a Malic. Once in a while they'll do, I guess they call it that 2% acidic solution that they'll do at once in a while if we ask for it. But our history is just a standard Malic test.
So the difference between that method and this one is that's an assumption. So they give you that story based on an assumed value of soluble nutrients over the course of the growing season. So it's a really high strongly acid extraction. And then they'll give you a number. They'll say, in parts per million, usually, of your nutrients. They'll say, this is what you have. This is the amount of soluble nutrients you'll have over the course of the crop cycle. I find that to be a little bit misleading because I want to see what's available today, what's now. And that's what I like about the Haney test, which were actually soluble nutrients now. This is what's readily available in the soil as we speak, meaning that if these nutrients are digestible nutrients, that's what we want to look at. These are the soluble nutrients that become available to the plant if they go through the right digestive system of the crop, meaning the gut. The only way these are normally processed is it's either in solution or, and that's why foliars work for you, or are the microbial colonies there that actually help move the nutrients through the root zone. And that's where we have a challenge here. These numbers here are challenging because what we're measuring here is the amount of microbial active carbon that's extracted. This is a calculation that's pulled out of the organic carbon. So what they'll take is it takes a piece of this sample, puts it in a canister with an X amount of volume of water, and they measure the amount of respiration coming off that. So what that tells me is over a 24-hour period, are there colonies in that soil that actually, what is the population of colonies that actually will help the digestive system? And in this case, this number is low. That 42 would be a low number. I like to see that respiration number up around 200 plus.
Okay.
And the only way to get that respiration number higher is to have higher levels of microbial colonies there that actually do that. And the way microbes live is off of carbohydrates. And carbohydrates are provided by a living plant normally, unless you can supplement them. But it's hard to supplement multiple billions of population of biology with just sugar alone. It needs the help of the plant too. The plant produces carbohydrates. So that's what this is telling us. This is giving us a soil respiration value, an organic carbon value, which is, in this case, organic carbon, I like to have that around 200, 225 to be very high. So that's not too bad. But then the microbial active carbon is a percentage of that calculation that says out of that organic carbon, how much of that is food for biology. So that's a measurement of actual carbohydrates. And then that give you that soil health calculation right here. And that soil health calculation takes into account these other factors, but mostly the biology, the actual piece of that that's living. So when you go through these and look, you can see that for the most part, they're pretty much the same. We have, challenging areas of soil respiration. Here's one that's as low as 13.
Yep, and that field, I'd say I struggle with that one. It's a little sandier soil, but it's that one makes sense to me that it's not as active anyways.
Yeah.
Just on a physical, when you go out there and look at the field and growing, it's nice land field, everything should be good, the fertility levels, but it's never available like some of these other ones.
And that shows up here. So that's why I like the genomics test, and I'll show you that. So when we look at the genomics test, which field did this come off of?
Yeah, 104 that's the first one, but the one that was struggling was 142C.
Do we have that genomics test or no?
I do have it. I don't.
Okay, well, you can look at that one there, but I'll show you why this corresponds with the Haney respiration story.
Yep.
And I'll show you that here so we want to look at the total species, which this is great. I like to see these up to areas like that, around 700. Fungi and bacteria, I'd love that to be 1-to-1, meaning we have higher colonies of bacteria than fungi. So how can we get higher, fungal colonies in there, which can directly contribute to the amount of respiration you're going to see. And so what this piece of the report tells me here is the plant in stress? Yes, it probably will be, because the biology is a little bit challenging, meaning that what is it going to do when it comes to response to being able to digest nutrients? So this story here is basically the one that we're looking at that kind of gives me that total story. Even though you had good adequate levels of carbon, if we go back and look at that report, we're looking at parts per million of organic carbon. You can double that, 250 pounds, roughly. This one gives you the total carbon for that field, which was 17,000. So out of that 17,000, you have about 250 pounds of that actual carbon that's going to be able to feed these organisms. And that shows up with this report. What it's showing me here is that the carbon cycle is not functioning fully. Now, this is the organisms that actually help the carbon cycle. We're not just measuring carbon here, we're measuring specific organisms that cycle carbon. So that's why we have inoculants that help do that. These organisms actually live on the root, right? They're not just in the soil everywhere. You have high levels of fertility, but these aren't just immediately available. They have to go through the gut of the biological organisms. Not say the gut, but the breakdown of residue in the form of fungi, yeast, mold, and then the way that bacteria solubilize nutrients. So this is an area that can actually be, and once you begin to add microbial colonies that help correct the carbon cycle, that directly shows up with this. You'll see these respiration numbers go up. They go up pretty quickly. And then when they go up, then it becomes the stress. The plant is not in stress as much. These low levels of microbial colonies causes stress conditions. And that's why you're seeing such good effective use of foliars. Because the plant's not picking these up naturally. They're sitting in a state of where they're hungry. And you can apply those and get responses with foliars. I prefer to see these happen, though, with higher levels of digestible nutrients. So I can show you examples of what I like to use Eric Sweezy's reports for that reason. When we look at the way nutrients are digested, there's an order of preference of sequence of how oxidative nutrients are picked up to the roots. And this is basically why I like this rhizophagy cycle, this diagram. Because what it shows me here is that traditionally in a soil, we know that carbon is rarely ever a factor that we look at in farming, because when we look at the amount of carbon that it takes to grow a plant, it's over half the mass of that plant is carbon. And it's creating carbon as well as it's picking up carbon. So carbohydrates become the factor. We ought to be thinking about how we can develop higher levels of carbohydrates rather than figure on better methods to help the plant pick up these cations and these other anions. So you can see that carbon's really the first in line for the other organisms to have a food source to be able to build the other the other nutrients that are picked up. Carbon, oxygen, manganese, iron, calcium, magnesium, copper, and then we think about nitrogen. And so in conventional farming, we've taken the NPK and zinc and we put them to the front of the line, and then what happens over time is we end up depleting our carbon levels. So having soluble nutrients is valuable, because then once you begin to build that function back, you can build really nice levels of, hang on just a second. Hang on. Again.
We were talking this morning on another one, Jim. And we were talking about the guys that go out and throw on a whole lot of nitrogen up front. That's what's causing their inefficiency in nitrogen and throwing that whole sequence off in the soil, because all the biology is headed over there to digest all that nitrogen.
Okay.
So it throws it out of balance overall.
Right. That's right. So what I like to do is I like to show examples of, guys that are actually showing how to build respiration, right? And build higher levels of microbial carbon. This is one of Eric's farms. Now I just did a basic here. Let me show the total. This is Meridian. So you see the respiration here on this one, 322.
Wow.
Microbial active carbon. Now he's challenged with carbon as well, but overall you get a better.
But he's cycling it though.
Yes, and you get better uptake. So this percentage. So this is on the genomics test. We're looking at that. I like to take that. So I'll show you that.
I was thinking the goal to higher yields to cycle more carbon, right? I mean, that's the whole thing. The more carbon we can cycle, the higher potential for nutrient uptake and yields.
That's correct. Once you get that carbon pathway fixed, the others just fall in place. So you can see what's blocking us here on yours is your carbon pathway is not quite functioning all the way. You're getting your phosphorus story is managed. You got it down pretty good. So these are the organisms that actually help cycle phosphorus. And then you're challenged a little bit here with your K levels. So these are all related to the ability for what really helps all of these pathways open up are the organisms that help build carbon, and that's microbial active carbon. So the goal here is to manage carbohydrates as much as possible, if that makes sense.
Yeah, so you kind of notice that my potassium pathways are not right either, right?
Right, I saw that as well.
So that, when I say that on grain corn or corn, on call it older tissue samples and current sap, I would say my potassium is 50-50 whether I am sufficient or low, even though I could say I have high levels of potassium, and that's been for many years. But in alfalfa hay, I don't have a problem getting potassium available to alfalfa hay. But in say grain corn or some of the other crops, wheat or whatever, I could struggle with potassium on and off through my. Yeah. But alfalfa hay in my manure program is an easy button. It's able to find it, and the only thing I could come to terms with that I was thinking alfalfa hay has more of an acidic root exudate, so it is able to, I call it, break that bond of potassium that say the microbial side isn't doing in corn. But alfalfa with that more acidic root exudate, it's breaking that bond and finding sufficient potassium.
Well, out of these fields we're looking at, which one is your alfalfa field?
Oh, not. So this one here, 104, it was an alfalfa before the corn, but it was 2 years prior. So usually alfalfa is in my rotation. I mean, in a standard rotation would be 3 years of alfalfa hay, a couple of years of corn, and then it go into either a wrinkled pea seed or wheat, and then rotate back in alfalfa. So alfalfa is my largest producing crop. My largest acres is alfalfa, and then corn. But
Well, the
but
reason you're seeing a better response is because, what is it, 3 years, or is that how long you leave a crop in the field in
yeah, it's
alfalfa?
typically 3 years. I'd say 3.5. So I plant my alfalfa behind peas or wheat, and then I'll get it established in the fall, and then I'll have 3 full seasons of alfalfa, and then on say the 4th year, I'll take a first cutting of alfalfa, and now I'm stripping corn into that and call it double crop, and I can take off 2.5 ton of alfalfa, and then plant strip till corn right into that, and that
Right.
works phenomenal. That's my best ROI crop that
I can see that. So what I would say you need to really do is get a microbial inoculant,
Yep. So
so
this
that you have living organisms actually helping with the process of this carbon cycling.
okay, yeah, this 166 is in alfalfa right now.
Yeah, I saw this at the bottom. That's
It,
why I thought.
okay, it's a new seeding. It was just planted prior to this sample the fall before this. So I think I pulled it in May, and it was planted the previous fall. So it's
So
a new
all you're
seeding.
doing on your alfalfa, you're just doing foliar treatments. That's it. You're not putting
No,
anything else.
no, I don't do anything on my alfalfa.
Okay.
No,
Good.
no fertility. I'll say I front load with manure in front of the peas or the wheat. I'll try to put on 20 to maybe up, try to get 20 to 40 ton of feedlot manure incorporated prior to my alfalfa planting, and then basically my alfalfa's anymore because there's not much value in it. I'm not. First, yeah, no foliars, no fertigating anything. The only thing I would get is adding boron or a little bit on my wheat spray because I struggle with boron. So that's about the only nutrient I'm applying on my alfalfa. It's so yeah, I have not seen a benefit for me foliaring on alfalfa hay yet.
Have you used
So
any early season, because you're still dormant there right now, right?
yes, we are dormant.
So have you, before your first cutting, have you thought about applying any carbohydrates and any sort of microbial inoculant?
No, no, I have not thought about it.
And
I guess
that's why these numbers are low. That's why these respiration numbers are low. Is there just not a lot of colonies there to actually do the function, right?
yep. I played with biologicals and corn in furrow, and I have not seen a benefit from them. And I was using some of Genesis Ag's products
Okay.
and furrow for 2 to 3 years, and then Wilbur Ellis, I used some of theirs. I could not see a visual on yield, and I could not see a yield on a yield monitor. I could not get more than 5 bushel consistently. I could not see lines, and even last year I had 3 different locations with multiple checks, and there was no consistency to seeing any benefit from these in-furrow biologicals. So I've struggled with them
Right.
on corn. But
What you need is organisms in there that actually can get the cycle working. So what I would recommend is some sort of a fungal colony product, something to help residue break down.
yeah, and that's where I struggled. So I guess a few years back, I knowing that I'm low on the call it mycorrhizal fungal
Right.
sources, I showed low early on. I mean, or I tried playing with Mycoply Endoprime. It was probably 4 or 5 years ago, and I did a bunch of strip trials on that in corn and peas. And I had a local guy up here. Oh, he's actually out of Oregon. He had his own product of a mycorrhizal fungal biological, and he come with his microscope and did samples before and after, and he could see the colonization before and then at different rates of the call it a couple of different products, and but the levels were so low that they still weren't doing any good. So I can't remember if you say there was say it was at a 7 count prior to applying, and when I did like a double or triple rate of a product, I got a say double the count to 14, but it still wasn't enough to do any benefit. And I needed I need to be at 50 count to even probably have a benefit. So I kind of conclusion my environment still wasn't good for the fungal side. Whatever I was doing was harming it. So
Yeah.
And I have not gone back to playing with those because I figured I got to change my whole practice of farming in order to create an environment where they'll thrive.
145. Hang on, guys, just a second.
When you talk foliar, Bo, you're talking through irrigation.
No, I'm not. No, it's true with the plane. I stopped fertigating. I tried doing that and trying to like chase manganese, magnesium, and it was very expensive, and I was seeing very little return on it. Especially manganese was the one that I struggled with, and so no, I'm doing my foliars are applied with either helicopter or plane.
And so when you say you're putting your nitrogen on foliar, how many gallons per application are you doing without burning it?
I've never burned. I go to 2 gallons of a nitrogen product, so the most I apply is 4 pounds at a time, and
Gotcha.
and I'm getting 2 to 3 weeks out of that on a sap analysis. And so like this last year, I applied my strip till. I had 8 pounds of nitrogen applied in my strip till with some thiazole, 3 gallons of thiazole, and 2 gallons of I call it the strategic. And the nitrogen is a urea, methylene, and triazone blend. And so I did 2 gallons on the strip till. So I had 8 pounds of total nitrogen on my strip till starter that I had. Okay. And then after that, I did 4 foliars with the actually only 3 of them would have been applied. The first one I didn't apply any nitrogen on at the V3 stage, but that's just a micro on that one. Yeah. But the nitrogen would start at that V5 stage, V6, and 2 gallons of a nitrogen product, which is like a 2.8% nitrogen, I think, on it. So somewhere in there, or 2.2, but it's about 4 to 4.5 pounds of nitrogen that I'm applying typically at a time. And I've had 0 burn, and I'm going up to 3.5, 4.5 gallons of FERT on there, and at a 5-gallon application rate. I believe like with the helicopters, the planes, a lot of times they won't dilute it either. They can put it on at the 4-gallon rate straight and 0 burn. I have not had any burn in 3 years on foliars on straight product. On going, call it I think the most is like just under 5 gallons total product, straight fertilizer.
Wow.
Never seen any burn. I got photos of it. You go out there a day later. I mean, you can see the stickiness, the kind of shiny spots, all the leaves, even on a standing corn crop there. They're down there at the ear leaf level with a plane and a helicopter both. And I have real fields that never get any rainfall or anything on it. And after about a week's time, you'll have little white specks on where those droplets hit, that the little dust on it, and that's it. But you can hold those leaves up into the sunlight, and you will be able to see. I'll call it a discoloring where those droplets had sit, but it's not burnt back. I'd say it's from a dark green to just a hair lighter shade. You can see where those droplets sat, and I think half of it is sunburn because when after the foliar, it's glossy, shiny, and you get these call it 90-degree days. I think it's more of a sun than anything than a burn. But whatever I use, I try to get as low a salt content as possible, and then throw in. There's always a humic in there, carbon source, and usually a little bit of seaweed too that goes in the mix. But I'm putting on as low a salt content FERT as I can get.
Yeah. So you're talking a low percent nitrogen, not 28 or 32 or something like that.
No, so I try to think what percent. No, it's would that even be 20%? Because it's that try to think what the math. If it's 9 pounds, it might be a 22%, 24% nitrogen is what's in it. Okay. So it's a lower percentage.
Good. That's awesome.
But it's strange how it works. But like on the sap, I mean, I've been going off the sap and that total nitrogen number, and that's my trigger point. Like I say, my nitrate and ammonium levels can get less than 5 parts per million, and that's good. But that total nitrogen number will hold. And it's been correlating to visual in 3 years when I've been doing it. I had fields that like last year, my worst field was 210 bushel. I could visually see the patches out there, and it showed up. And when that total nitrogen number on the sap gets below, I'm going to say 1,200 parts per million, it's starting to it's starting to rob. you know, and,
Mm.
and with the sap, the old leaf, new leaf, you know, of course, that's the easy part following those,
Yeah.
but on that total number, that trigger point, as long as I keep that nitrogen in that 1400 parts per million or above, I'm not seeing
Yeah.
any visual, and I'm getting 2 to 3 weeks on this rapid growth stage of the corn. I'd say the B8 to B12. I mean, it's pulling a lot, and I'm
Yeah.
I'm going 2.5 weeks with 4 pounds of nitrogen, and I've done it for a couple of years, and it's holding. So it's been odd how what it's shown it's doing, that I don't need the nitrogen, but still trying to get an understanding of where that nitrogen's coming from, because I know the plant's finding it, it's utilizing it from somewhere,
Yeah.
and
Well,
and it's not mining the soil.
I want to
It's
show you
it's
the
not
difference.
soil either, because my soil samples are basically unchanged with going foliar compared to if I put on 250 pounds of nitrogen, my soil sample can look the same as I put on 25 pounds, you know, at the end of the
Yeah.
year. It's on the soil sample. So it's the standard soil samples are not telling the story of what's happening out there.
Wow.
And
But
that's
look
what
at this.
total nutrient digestion is man, it just changed my whole mindset. This is what we're working with, and this is what we have to make available. This is our true bank account, and trying to figure out how to unlock that number is where it is the whole ticket. And so
Yeah.
it's a whole way of looking at it. And when I look at what Kevin's doing with his crops and everything, I think his soils are so much more active, and his corn can tap into it. If it's having a good day, I mean, yeah, or a great day, he can do it so much better than his neighbor's soil, because his soil is his soils are releasing what the plant needs. Because
Yeah.
I come to terms with I can't manage or micromanage my crop better than just leaving it alone. But if I can change that environment where it sits in and make this my soil bank available, that's gonna be the game changer for me. But like I say, that I guess that's why we're here, to try to
Well, look at this.
understand how to
Look at
change.
this total. Look at this total nutrient report I'm showing you here. This is a hay grower here close by me. So this is western Arkansas, eastern Oklahoma, just to show you the difference in his total nutrients versus yours. 60,000 units, 60,000 pounds of carbon, 6,000 pounds of nitrogen. You can tell you're in a different kind of situation.
So
Yeah.
what percentage organic matter would that?
I want to show you right here. 5.
5. Okay, and I'm 1.5 to 2. So
Right.
yes, you double the organic matter, then everything just basically increases the same fold, doesn't it?
Right. So then you look at the total net, but you look at his P levels compared to yours, 15 pounds.
Huh.
So, and his potassium
Wow.
levels is 20, right at 40 pounds. His nitrogen's 30. So here's a guy that has really
Wow.
good potential for building soluble nutrients, but he's got a really high level of nutrients in his totals. See these high numbers?
Yes.
But his available numbers are really low. So you have a
Wow.
challenge with biology because you have really high levels of soluble nutrients and low microbial colonies.
Huh.
He's got low nutrients and decent microbial colonies. So
Wow.
he's using manure. I've got him using chicken manure from the local manure to help with his functions, where you're just the opposite. That's why I wanted to show these two different tests.
Man, it's just
Day and
gets more
night,
complicated, doesn't it?
day and night. But he's challenging. It's challenging for him to do as well, because he's getting his information from the local co-op that's telling him he needs
Yep.
to apply potash and P2O5, right? And high levels of
Yep.
nitrogen. And so I got him away from that because those salts are causing him problems. And
Yep.
so what I want to help him do is say, you don't need a lot of nutrients added. You need a lot of soluble nutrients added. So he's on the track to doing some good stuff, but he's got beautiful organic matter. He's challenged a little bit with his soil respiration. So in the same thing that I would tell you is that whatever we got to do to get more fungal colonies in your soil,
Yes.
the better, right?
So
to help with these numbers that I'm looking at here. Yours, get these numbers up. I want those up to around 200.
So do you have a quick answer on how to provide a home for those fungal colonies to support? Because I mean, it's easy enough to inoculate or apply products on, but
you inoculants they're not good without a good microbial carbon. So that was what I was going to ask you. Are you using any kind of carbohydrates at all? Any sugars?
Yeah, a little bit of sugars. I've used some molasses in the past, and then I'm using most of my foliar sprays. I mean, if I'm on that, but it's very little. It's carbos, and so it's. I mean, yeah, 2 to 4 ounces an acre on application is very, very little,
right,
of a product. But in the past, I was playing with the molasses, anyways.
do you have a source to get carbohydrates? I mean, I know Monty's has some good carbohydrates and good carbon.
Yeah, that's the problem where I'm at in the PNW. I mean, you get the Monties. I mean, it cost me double to get it here,
right,
compared to what you guys. So that's when I look at like the molasses. Yeah, at $2 a gallon, I can have it delivered to my place full. It's pretty good, and it's called feed molasses, cane molasses. And I played with that in the past and been fine. But
so what I would do is I would take that 2-gallon rate or 4-gallon rate of molasses and apply an inoculant in that. And some, like we have a product called Innovate that would do that, to give you the fungal colonies to where you can actually get out and put those on the surface and begin to start breaking down that residue. Once those colonies are there, you'll notice the respiration number really changing. And then you recharge it and get that function going again.
So in my mind, I kept thinking that there was always some percentage of fungal colonies there. I mean, even you say if you did
there are test, some.
They're very low. So and then the amount we put on, it seemed like we're just pissing in the wind with the amount that we're putting on compared to, and if the ones that are there are dormant or not in the right environment. So that's why I keep going back, man. Never seen success with some of this stuff because we're putting them in a poor environment. Call it,
you need to stimulate those that carbohydrates. So I would say in the season when you're treating your alfalfa, because that's your energy source. That's a permanent crop, and it's trying to build up higher levels of carbohydrates and what we call microbial active carbon in the soil through that living root. And so if you can keep a good source of fungal colonies growing in there during that season, then that'll begin to start recharging when you do rotate into corn or peas or whatever your next crop is.
So what's your thought on root exudates on sugar for carbon source? I mean, that's part of the idea on these foliars is if I can stimulate that plant in a 3 to 6 day window, get everything balanced right and get those root exudate flushes, and then start looking at what these crops they say potentially they release in, I call it gallons of sugar or pounds of sugar per acre. I mean, it's like, we'd want to, if we can say corn, a 300 bushel corn crop needs or can produce 30,000 gallons of sugar glucose per acre. I mean, a lot of it's used for its own energy, but if it's fat and happy, its excess will feed. So it seemed like, man, there's more in my mind. There was more potential with a good foliar than there was, say, a molasses or carbohydrate product. If we could get the plant to do it itself, we could. I mean, it was like a 10-fold or 100-fold what of that energy could be put into the soil.
Right, and then here's the best. So let me ask you this: when do you put out your manure? Every winter?
Either the fall or spring. Yes.
And it goes out in liquid.
No, it's dry.
Dry.
I call it. It'd be a 40 to 60% dry matter, depending on timing and when we're getting it out of the field.
Is it composted or is it coming right out of the?
No, it's straight. I've done the compost in the past, and I did not see the benefit for the extra labor and it takes. I've gone back to raw manure instead, applying raw manure, and it goes the manure spreaders. These newer vertical bead manure spreaders do a phenomenal job of spreading anymore. Where in the past I call it dried screen manure. I would compost it, turn it, 5 times, and I was sizing it down and then spreading it. But the analysis on it was exactly the same, except for maybe the ammonia levels would be a little lower. But the rest of it did not change. The only thing that changes, I'm reducing particle size and moisture by composting. What I was doing, it's not a true compost.
this source of manure has been, what's the food source? Are they using just, is this feedlot manure?
Yes, it's feedlot. So it's the diet would be alfalfa hay, grain corn, potatoes, and then supplements in that. But it's typically I say hay, corn, potato ration.
Well, that would be the place where you'd want to get an inoculant in to help, because by itself, you're right. The rates in an inoculant are small. They can't just
Yep.
function on themselves without a good carbohydrate. So you want to get those organisms in there to feed off of the carbohydrates, those 30,000 gallons that the plants produces per acre in a corn crop. And it's showing up here in your reports as it's challenging because we have such low respiration levels. And so there's a condition here that needs to be addressed, and it's the stress story. See it here?
Yeah. Yeah, they don't look very good.
So that tells me that we got it. You've got food, you've got organic matter's not too awfully bad. I mean, was it 2? For the most
Yes,
part.
this one, I think the one was,
But this fungal story is what's causing you to have a limited ability to get the crop response. And that shows up here with the genomics too. We can see that in the top. It shows that I like to see this fungal story here to be about 10 million units or higher per gram.
Okay.
So you're at 1 million here.
Yep.
And that ratio is not too bad. I've seen much worse. I've seen these high as 1 to 30,000, but
yep. And it's funny because on that, on these samples, say 8 different fields in 3 years, I've had from a 1 to 3 ratio to like 1 to 28,000.
Yeah.
And it has not correlated with what I thought is my healthier fields or better fields either. So, and granted, it's I'm taking them in May because that's the first year I took them. That's when I got prepared to take them. So I've been doing them on the same time frame every year, within the same week, anyways, every year. That in May, I believe, is when I've been taking these samples on the same fields. But that number's jumping up and down.
Are you pretty happy with your yields you're getting though with your foliar program? I mean, you can.
Yeah. So I think on corn, I'm average 260 bushel.
Good.
So it's good. I would say in the past, I mean, I've been up in that 280s with the full fertility program, but reality, I'm going to say I'm within 10 bushel of my neighbors, and most of our yields is reflected on weather. Call it an early spring, long fall. We can get another 30 bushel easy. Everybody will have it, regardless of your farming methods and your inputs. So yeah, so we've been down a little bit. So yeah, no, my yields I've been happy with. Like I say, my yields are holding but I'm dropped my inputs. But the thing that's not really measured is my soils are getting a lot better with my reduced tillage and my reduced salt inputs. I can tell my soils are changing. They are getting better and doing some cover cropping and a little bit of stuff. They are getting better, and that there's no measurement for that for the long-term success. But so I'm happy with what I've done, because of, like, when reducing tillage, that's saving me $150 an acre, and I'm and my inputs I've probably reduced that by on fertility $100 to $150 also. So even saying I can save $200 an acre, and if I'm only 10 bushel off my long-term average yields in my neighbor, I'm doing good.
You're winning this game. And I tell you that the only challenge I see you have is, I know that's because of the soil type and the conditions you've got, is this microbial active carbon story.
Yes, but I was one thing that changed my soils faster than anything I did was alfalfa hay. 2 years ago, I left a field instead of taking a early cutting and rotating into corn. It was my worst producing field, kind of a new field I've had. And I left about 1.5 ton of alfalfa hay. I killed it or sprayed it out and strip tilled right into that. In doing that, leaving that 1.5 ton of that alfalfa hay melt down in that soil, and I stripped corn right into that. It went from my worst producing field to my best producing field in 2 years, the last 2 years.
That tells you the story right there.
Oh,
how valuable that carbon is, that microbial carbon is.
No, and that's what it's trying to figure what the heck is going on. And so I just went off of earthworm count. So I went from 0 to 2 earthworms per shovelful at the beginning of in the spring when I stripped tilled corn to 10 to 20 in the fall.
Yeah.
And then I had 292 bushel on that. I took off. Well, I didn't take off the hay, but it was 1.5 ton of hay I left there and got 292 bushel. And then 2 years ago, then last year, I did put on, no, it was 10 ton of manure. I top dress on the corn residue and I strip till it. So I pushed all that manure with the strip tiller with the row cleaners between the rows and all that residue and left that manure there. And I had 310 bushel corn with 22 pounds of applied fertilizer. And
what a story.
But the strange part is I've never seen soil tilt in the Columbia Basin where I'm at. And that all of a sudden you see all the worm castings and actually seen that, call it brown chocolate soil. Never seen in my life. I mean, my family has iron deficiency syndrome. We love the plow, love tillage, grew up that way. Everybody around us, there's a lot of vegetable seeds grown in our area, potatoes, onions. So everybody tilled. I mean, that was it. And we love the smell of that and that. So I've never ever in my life seen tilt, true tilt. And I had 1 inch of what I call tilt of, you could see though, that aggregated soil and sticky, chocolate cake soil. Never seen that in my life. And it showed up in 1 year.
It does. Yeah. It's amazing how quick that'll show up.
And we're just with leaving that alfalfa hay, instead of taking off, I could have got $150 an acre selling it to my neighbor dairy to green chop it off. And so that leaving that $150 of that 1.5 ton residue there just changed that soil profile for 2 years now. And it's unreal what it could do, that alfalfa hay. So that's trying to figure out, okay, what is unlocking these soils? So, and when I go back,
are you going to continue to do that on the other rotations?
Oh man.
Can you afford it?
That's the problem is, yes, you should do it. I know I should, but I'm still, it's if there's an early spring, we've had selling it 3 years ago, the alfalfa hay returned $600 an acre profit selling it to the neighbor.
Right.
Hay was $300 a ton, 3 years ago. Well, last year it was worth $100 a ton. So, it's a difference. So when it's $300 a ton, yeah, sometimes you say you can't afford not to, but the reality was, I gave up $150 and it paid itself back the first year. And then last year I was $50, 50 bushel above my farm average on that field. So 50 bushel, at even say $5 a bushel or $4, I was ahead $200 the second year. And that's not giving credit to my soil is in better shape. And so my third year, it's still going to pay back.
Yes.
So that's, yes. It's one of those things you realize that, you reaping the rewards one day, but by leaving that, I know I will be better off leaving that alfalfa hay. And that's what I learned with the alfalfa hay, that is that the protozoa and alfalfa hay is earthworm's favorite food. So it just changed the earthworm population. And once that earthworm population, it broke my soil open, because that soil following alfalfa hay is compacted and hard. I mean, I couldn't get a penetrometer in the ground on alfalfa hay on some of this ground. It's hard. But even you go out there, even after the worms and all this, the ground is still firm, but it's opened up with those earthworms and it's breathing and it's becoming biologically active. It's still compacted in hard soils, but it's crazy how just having the earthworms, even though it's hard and compacted, it's active and it was alive. It changed it. So I know coming this year, I'm going to leave a few more fields, leave the stand of hay there, and not pull it off and sell it off, because like I say, hay still isn't worth anything. So I'm going to leave a lot of these, get the corn a little earlier, and try to leave at least 18 inches, 12 inches, 18 inches of alfalfa growth there to melt down as a cover. And
what do you? Let me ask you this. So what do you think about the measuring methods we've been looking at here? Looking at the Haney, the total nutrient, and the B crop. Does that give better insights on what you're actually seeing instead of just?
I'm going to say the total nutrient digestion is. I'm going to say that's a must for everybody. Should have that, because that is your true bank account.
Right.
Or what's, and then the Haney is it's even better than the standard Malic. Yeah. The B crop is still it's still the tough one for me to comprehend. But yeah, like you say, that bacterial to fungal ratio. I think that's another striving goal. But this
Well, I
test,
think the bee crop, once you understand what you can actually see with the Haney, the bee crop becomes
it, it changes it. But I know after 3 years of taking the bee crop samples, I mean, I think it's a lot of it. It's just the time of year, the crop rotation, the tillage methods can have a huge influence on it. So it's extremely volatile test where it can be look really great one year and the next year it's horrible is
yeah,
what I've seen.
right.
And then the third year average. And
Yeah.
so it's definitely, I would say it's not one you take a single snapshot and run with. It's like, say, take 3 years and then, but so going back to the Haney is a lot easier to comprehend and
Yeah.
give you a feel for whether you're got, call it good, healthy, active soils or not.
So I developed 2 different tests. One is what I call a basic test where I just take the total nutrient and the available. So it's just Haney data versus a total nutrient test.
Oh, yep.
I do this as a snapshot so we can actually, and I show this example of this pivot with this cut across the top. And,
Yep.
and the guy goes, "Wow, man, I've tried Malick data and everything tells me I need to use it." I mean, the fertility levels don't tell you that much. But what I'm trying to show him is with a Haney data and a total nutrient data, we have a different story. So just consider this area here as a composite, and we did a composite out of that strip. This is where a pipeline was cut across this pivot a few years back. And so here's where the area is using the total nutrient and the Haney and the soil health calculation. So here you can see the microbial active carbon number, the organic matter, the respiration. And then I want to show the available nutrients. Now yours would be much different than this because yours are way up into 150 on total phosphorus. But what I
Yeah.
wanted to show him here was by using a total nutrient and a Haney, here's your total phosphorus levels. Here's his total phosphorus levels on where the cut was. He's got higher total phosphorus, low available phosphorus, only 4 pounds.
Yep.
Respiration's at 70, microbial active carbon's at 32. So you can see that he has a biological problem here, not a nutritional uptake problem.
Yes. That's it. Kind of laughs because that kind of correlates years ago. I mean, manure around here was not very sought after. Nobody wanted it. It was a, call it a 4-letter word. But we had we call it Warden white soils. There's these real white ashy soils and very unproductive on these like hilltops with potatoes. We had some neighbor farmers with potatoes who applied call it dried screen manure on that, even at like 3 ton an acre, and it turned those that call it low active, biologically active soils from the worst yielding to the best. And like in potatoes, it went from where they couldn't even get row closure on these potatoes to just 3 ton of, call it dried screen manure. It closed the rows first and died last in one season. And I seen it too on our own soils where using where some of these, I call these low active soils where the nutrients aren't available years ago. The highest yields I've ever seen is on these, I call it poor white soils that look like low biological activity. But sometimes if the weather is right and conditions are right, the nutrients release, and we got our highest yields ever we've seen on some of our farms from them. And corn on it, I think got some into, call it in the 370s, on this typically horrible soils. But if the conditions were right, environment, the sun hitting right, the crop rotation, all of a sudden they unlock. And
yeah. Are you irrigated? Is this irrigated corn?
Yes, 100% irrigated.
Oh, good. Okay, so you're around the Tri-Cities area then.
Yes, I'm 50 miles south or north, north of Tri-Cities. So yes.
Okay.
Yep.
I know that area pretty well.
Yep. So I'm the Columbia Basin project. So
right.
Yeah. So we're 6 to 8 inches of annual rainfall, about 180 days growing season.
Okay.
So, yep. Just Tri-Cities probably got a couple weeks on me where I'm at. So
what we need to do is we need to get. This is one of my irrigated farmers. I'm just going to show you this, what an inoculant will do. So what we need to do is get your field to look like this. Can we get those fungal colonies in there growing like that during the season?
Yep.
Do you have a lot of residue in that farm?
Oh yeah, it does not break down. Even with manure program and all that, my corn on corn strip till, I will have residue 2 years old on the surface. It will not disappear in a full season.
Yeah.
The second year it'll be gone. It'll disappear, but my residue from will last a full extra season. From last year's corn will last all the way to the end of the next crop. You'll still find residue on the surface.
Well, that would be the number one objective I would do, is focus on getting microbial carbon in there and then getting the inoculants in there to get those fungal colonies growing, and work on that residue, and that'll change the whole game.
So on inoculating fungal colonies, I mean, even fertigating, or what's the best way to get the best ROI on it? Or, I mean, an in-furrow?
I would apply them whenever the season's warm, right? Whenever you can get active colonies in there to grow.
Above 60-degree soil
Yes.
temp or warmer?
Yeah. Right.
Even better, the better the odds are than even if you go into the summer, but just get them established.
Yes, get those colonies established to where they start working that residue. And then once you get those colonies in there, you manage them, but try to do anything possible where you don't kill them. And that all has to do with tillage practices.
Yep.
And glyphosate, believe it or not, is pretty hard on them. So if you're going to use glyphosate as a burn down, then, come in with colonies and re-inoculate.
Okay. I've been reducing my glyphosate in half. So even from what I've been doing, even like on the corn or burn down on the hay, I mean, I guess 20 ounces of glyphosate, and then I'll come the same with the in season 20 ounces, and that's it. But I haven't got away from it though. But so yeah.
So we have a
but I'm not,
product that does that, and it's Innovate. That's our product. It's designed. It's mostly all fungal colonies, well over 200 species. That's probably not a product you use from the past.
but do you put that together with? No, you wouldn't put it together with the glyphosate, would you? You would have
No, I would
separate.
You could do it, but yeah, I mean, I got guys doing it, actually putting in with their glyphosate.
Okay, because I'm gonna say if I'm doing foliar anyways, and planes up in the air, I'm gonna say 4 to 6 times.
But I would prefer, if you're going to do it through, a spray
Throw it
pass,
in,
or
throw it in with foliar.
Yeah.
Yeah. Post glyphosate application in the season. I mean, say my glyphosate is typically at that V3, V4 application. So I would say in mine is at that V5, V6 foliar. That's the time to try to re-inoculate and get it established through the season.
Right. Yes.
Okay.
I mean, I could recommend a bunch of other things, but your nutrient levels are so right in, man, they're perfect, really, when you look at it. I mean, every farmer ought to be as lucky as to have those high levels of nutrients.
Yep. But I know manganese is the one that I really struggle with, and come to learn that, I need high fungal colonies in order to crack the manganese too.
Did you see when I showed you this available levels of this right here, manganese?
Yes.
So these are all on the left are all fungal related organisms, all the way into where you get into calcium. Then we start talking more bacterial.
No, I'd say when I looked at that, that's what I said. My roadblock was at manganese. I mean, step 3, my manganese is crashing. The iron has been okay, calcium okay, but manganese, I struggle. Unlocking it, and that's kind of where I'm going to say 3-4 years ago changed my whole path or whatever. And it was listening to John Kemp talk about it, explaining the manganese, the chemistry lockup, and then trying to reduce oxidizers. So that's when I went into heavy with. And then Kevin preaching low salts, and I kind of married those two concepts of extremely low salts and reducing my oxidizers is where my farm's at today.
Yeah, that's good.
And it is changing and stuff. So, but I know in my mind, I know the fungal side of my soils are poor, and the manganese is low, because like with my manure program, when I take my manure analysis every year, I'm applying twice as much manganese as any crop would ever remove that I've been growing, whether it's alfalfa hay, silage, corn, potatoes on in the rotation. So I should have extremely high levels of manganese, but I found out it's not available. My soils show very low. My saps and tissues show very low on manganese, and And then when I was trying to fertigate manganese, I could put gallons on and would not see a response, or I'd see a short-term response for 1 to 2 weeks, and then it would go back to low again. And those times I, spend $40-50 an acre on just fertigating manganese products to see it, and it would not hold. Whereas when I went to foliars, I could spoon feed and I could see it would get sufficient, but never good. It would just get to the low sufficiency level is the best I could do. And there was a few fields, some of the fields once in a while, I see it unlocking. This last year, I see on my saps on, I think I had 10 fields or 12 fields on corn I was pulling, and I could see a few of them starting to unlock once in a while, but not consistent.
Yeah. Well, you can see when the order of oxidative extractable nutrients, you can see why manganese is probably challenging in your farm because of this respiration level shows that we're not getting a lot of,
Yep.
biological activity. Well, and that's Joe wanted me to kind of show the standard method. I mean, it's hard for me to give a soil health report when we look at these kind of reports coming out of conventional agriculture. You know it? I mean, this is all fertility ratings.
It's a total different mindset, isn't it?
Yeah.
What do you basically almost got to forget about the old way and what you do it and put the blinders on, don't you?
Yeah, you do. I mean, this really is hard to take this data and put a biological program together because all we're looking at is fertility management.
No, that's a history lesson is all you can say. It's good to know the past and what caused that, but yeah, moving forward, it doesn't mean a whole lot, does it?
No, it don't. And that's what I hope more than anything else out of these calls is to get you guys to see why we want to develop these different tests, looking at the Haney test, total nutrient and genomics.
Tell him where that's at. This is in Ohio. This is Adam Miller in Ohio.
Yeah.
Oh, okay.
And I'm not trying to criticize it. I mean, I love the data sets and the way they've done this and the organizational skills, but the Malic 3 data is not going to help us fix a functional issue.
I kind of laugh because I was religiously always pull soil samples every fall or spring at the worst, and every year. And this last year, I didn't get around to doing it because I hate to say it wasn't as critical anymore. I kept thinking it gives me false hope of what's there and what to work with, and I'll pull them again and get them pulled in the spring another year. But every year I pull soil samples, but and my mindset's changing that it's more or less looking at soil health and plant health. Means so much more if I can dial in on that and ignore some of the soil health, because I know with my manure program I've taken these total nutrient digestions, I have fertility there, so yeah, it's
you do.
My most important thing is the soil health, trying to do the best I can with my rotation and change my tillage practices and fertility practices in order to unlock all this.
And so what I've compiled, and I've showed it before on our calls, is taking all three of those tests and turn it into one report.
Oh yes.
That I do right here. This is what.
No, that's.
So this is a total, what I call a soil functionality analysis. Now I don't have all the nutrients on there. I'll go all the way. I go carbon, nitrogen, phosphorus, potassium, calcium, zinc, and sulfur.
Yep.
But I want to be able to show the total species, what the soil health calculation is, what the respiration number is. If we're going to produce hormones, stress adaptation, this all comes off the genomics test. The biocontrol agents, are we going to be able to fight stress? If we do have a fungal pathogen, what is the disease risk, in this case? And then total on the left, available on the right, and then the percentage of pathway, how it's opened up in the center. So let's take all three of those and put it into one report. And I'm kind of thinking this may be kind of something that becomes a standard method for looking at soil health.
Yeah, I think that's a great way to look forward to. Something that's easy enough to read and give you a report card.
Yeah,
it's got to be simple.
Right. I just
like that.
We're building at BTI. We're kind of beginning to build what we call a calculator, so we can take data over time and develop like they've done there with ANL Great Lakes. I think is who this lab is developed. Yeah, ANL Great Lakes lab, where we can actually have data coming off our soil health functionality analysis. similar to what they've done with Malik 3 data.
Oh, yep.
But they're just nutrient level. These methods, and we have learned, history's shown us some lessons that these are all based on fertility inputs, and we're finding out now that we got to look at different indexes.
So Al, on this farmer here, Adam Miller, that you're looking at, and he doesn't have all of those tests that you've been looking at. So what would you say to him to start out with? Regardless, we don't really know the information we have, but assuming he's got in-furrow, 2x2, and wide drop, what would you suggest he start with to try and improve something?
The only thing I have to go off on these Malik tests is your organic matter.
Yeah.
So that don't tell me a lot. I mean, it's fair. It's good. It's not. But when I look at the parts per million of soluble nutrients, remember,
Yeah.
this is going to be a different number. Now, I can tell you that there is a correlation between phosphorus extracted from the Malik and the phosphorus extracted from the H3A.
Yeah.
Well, that number there is going to be about 60 pounds. That potassium number, I don't know, it's up in the air. You remember on the last call, Joe, I showed you the difference between what
Yeah.
potassium was with a
Yeah.
Malik extraction versus what it is with a Haney.
Yeah.
There's a factor there. It's usually like 2.5 times. But this doesn't really give me the insights that I need to look at when we look at the function. That's why respiration and microbial active carbon give me a better
Yeah.
story, because now I can see that, are we going to digest these nutrients? So this test here that I was just showing, well, I'll just show Caleb's. Similarly, I mean, you would think that if he was to take that Malik data, he would go out and buy fertilizer.
Yeah.
Based on this, because he's only got 15 pounds of P.
Right.
But when I look at the soil respiration number and organic carbon and microbial active carbon numbers, that makes this what I call this an efficiency factor. He has a better efficient use of this P with this kind of a soil health calculation. And it's not the top of the world. It's a 12.4. I'd like to see those around 25. But he's going to get a higher level of absorption of nutrients with this kind of soil health than he will on one that's, got low
Right.
respiration. So when I'm looking at this data, I'm going, I don't know what, probably very low efficiencies. I would suggest you do a Haney test.
Well, and he may do that, and I'll encourage him to do that. But you mentioned the organic matter, but right there beside it, the CEC, that's a somewhat sandy soil. So that's
telling me
another
that and that's the old model where we've thought of how cations are exchanged on these cation exchange sites, telling us if we have clay or sandy soils.
Yeah.
So he's going to have a base saturation number that's going to be affected there, and it's probably going to be mostly calcium because that's what he's got here.
Yeah. Yeah.
And so what we thought of in the old traditional school was, man, I've got all my exchange sites are filled up with calcium, and I don't have any ability. I need to get more, available cations. So that's why they show these here on the right with the percentage of how much of those are tied up into what we think the cation exchange sites. I'm finding out now that I look at it through this different lens, that the plant is going to take those nutrients off of those exchange sites if they need them. I call it nutrients on demand. So you got to have those columns there that actually solubilize them. So I'm not all that concerned about exchanging nutrients on clay particles anymore, or organic matter. That's kind of the old way of looking at it.
So this is a strange question, but if you introduce your fungi colonies and they start building, will you actually increase the EC?
Yeah.
That's what I'm thinking.
Yeah, you will.
Yeah.
Mm-hmm. Yeah, you have higher organic matter levels and more cation exchange capacity. Yes.
Yeah. Okay. Yeah, and I'll get back with Adam and get him to pull some of those tests. And I think we have David, is that you on with Kyocera.
Yes, it's me.
Okay.
Want to look over some other reports, right?
Yeah, those others that I sent you of right
This one.
there. Yeah.
So
You've
what
been
we're
taking
looking-
you've been taking a bunch of this in, David. I'm sure it's a little bit Greek to you at the moment, isn't it?
Yeah, a little bit.
Yeah.
So this was the data you sent me. So I got a total nutrient, a Haney data, right, and a Malik
Yeah.
theory.
Yes.
So what I wanted to really have you focus on was the amount of total nutrients. Did that come as a shock when you saw that?
Yeah. Yeah.
I circled that because that's how much fertilizer is sitting there in our soils we don't realize we have a lot of times. And so the challenge is how do we make these total nutrients become more available? And so I recommended some things here on the bottom, but the difference in data between a Malik 3 and a Haney was really what I wanted to kind of focus on here. So what they done with what they use is, in this case, they use a KCl extraction to give you your nitrogen number, and then they use Malik 3 to give you your P and your K and your other trace minerals. And so I don't know who did this. Was Region that did this report.
Yeah.
So he
Well, he requested a Malik 3, I believe.
right. So when you look at the Malik 3 phosphorus, and that's why I kind of have this circle here, it's 174 pounds per acre versus what you would see with the Haney at 106. And the reason why is because this is actually an assumption. This is not really based on available nutrients that are right there. So they use a real high strong acid. That's why I explained it here what the extraction is when I laid this out here. And the whole goal here is to show you that this is 174 pounds available over the lifespan of the crop. So this is based on 140 days, 150-day life span of time. Whereas this one is telling you what's available right today, right now. And so the reason I like this test is because it more closely resembles the environment the plant's growing in. And we're not assuming a bunch of stuff. So here we're looking at potassium levels. I put it in there at 200 units, 200 pounds. Here we're at 160. So we're not that much off, but this is more accurate, in my opinion, because we're using more closely. We're using water and 3 different organic acids that are more closely resemble to the exudate of the crop of the plant. But what a Malik 3 doesn't give us, it only gives us fertility levels, meaning that in this case, you probably wouldn't want to use P or K, but you'd probably want to add nitrogen because it's only showing you at 16 pounds. Whereas on the Haney test, the nitrogen is going to show you double that because they're measuring organic nitrogen. This test is only measuring one extraction using 1 NKCl extraction. So, but the number one thing we were talking about that earlier, is this soil health calculation. Is that in order for us to digest these nutrients, we need to have levels of carbon that actually become food sources that can feed these microbial colonies that do the work. And that's kind of a challenge a lot of times when we continually put products out there that deplete these colonies of organisms that do the function. And so as you were hearing Bo and I discuss earlier, we're talking about fungi and bacteria and the role they play. Well, the way fungal colonies work is they help break down carbon and reduce nutrients that are already soluble through the plant residues and also in the soil. But that's measurable in respiration so we take a soil sample, he'll take the H3A extraction, he'll take water, he'll extract organic carbon, organic nitrogen, and then he'll take that beaker and measure the amount of carbon dioxide that's released over 24 hours, and that's measurable. And what that's doing is it's telling us the population of organisms that's living in that soil. So we want that number to be up into the, for respiration, we like that to be on above, I would say 150 to 200 parts. Then that tells us that we have colonies there that can actually begin to start digesting nutrients. So that's how this all ties together. We can't do that with a malic extraction. I have no idea what the organic fraction is there. I can tell you what your organic matter is. It's 1.9%. But this tells me, do we have actual living organisms that are doing the function? So the way to build that back is to be able to get more microbial active carbon there. And that's going to be in the form of carbohydrates. Plants produce carbohydrates through their natural process. And they don't function better unless those carbohydrates are feeding good microbial colonies. So building microbial colonies back in the soil is a function that requires our inputs as farmers. Lower rates of tillage, more cover crops, more living plant roots in the system, and then inoculating with, organisms that actually help live on that root system and build better levels of microbial carbon. So this is good. It gives me a good snapshot of what's going on. We got good levels of nutrients. Nitrogen is a little challenging, which you can fix that with a good soluble form of nitrogen, and then building back these microbial colonies to get better functionality. Any questions?
The only thing else that you need in this whole scenario, David, would be a bee crop test, so we could see the whole big picture of how many biology that you've got working in your soil.
Uh-huh.
You can't fix these kind of things with applications of fertilizer and more tillage. I mean, we just got to get more fungal colonies in there. I could tell you probably you're going to have a pretty wide ratio of fungi to bacteria. I would bet it's going to, because of the respiration levels I see, it's going to be 1 to probably 600, 700, something like that. I've seen enough samples to be able to show farmers that what we're challenged with is getting more more fungal colonies in the system.
Okay. I mean, I'm sure we're behind on that. Our big problem has always been phosphorus because of the chicken manure we've used in the past.
Yeah, this is good. You got a good level of phosphorus here on this report.
Yeah, well, you think it's good. The state of Maryland doesn't think it's good.
They think it's too high? What do they think it is? Too low? What does the state of Maryland think?
Think that we shouldn't have had any for years.
Look at this one I was just showing. This is my neighbor up here. Look at his phosphorus on his Haney test. But if I show you his total nutrient levels of phosphorus, he's at 782 pounds. So what I'm able to convince him to do is to come in here and solubilize that phosphorus with KPhos. So that's what we're doing. That's what we're doing with this farm. We're adding KPhos and then innovate to get more fungal colonies in there. But his soil health, his respiration's pretty good. And I mean, I like to see it a little higher. But it's getting better.
Al, so David just joined the MAC group. So all of this is brand new to him. He's not heard any information about this before. So when I send you this video, David, you'll pick up on the first part that you didn't get to hear probably. Bo is out in Washington State, and you're all the way across the country on the other side.
I heard most of it.
Yeah. But what we're doing here is trying to zone in on what a lot of farmers are missing. They go out and put on NPK every single year, and they're just pouring more and more salt to the soil, which is suppressing their biological process as well as some of their fungi and bacteria colonies.
Yeah.
And what Al's product's doing is building them back so that the biology does the work for you, not the fertilizer.
And that's kind of what drew me to you guys, because for probably the last 5 to 7 years, I thought we put on too much salt.
Correct. You're right.
Trying to find a way not to do that.
Yeah.
And that's why I like this soluble salt report, the peacefulness report. If that gets up to 0.4 or so, then I can tell you you've got a salt issue. And I've seen them that high. This is not too bad. I like to see that around 0.01, 0.05, 0.07. But the factors that affect our fungal colonies for the most part are high levels of glyphosate or any other herbicide. Fungicides continually seem to be able to break down those fungal colonies over time. Tillage practices. The big one is potassium chloride.
Yeah.
Potash. Just dropping that's going to change everything. Those inputs. I mean, managing them. And then coming in and inoculating with good colonies that actually help build the soil health back. So you're in a good group, but this group will help you really align with the way this whole function works and the way growing plants without dry fertilizers works.
So David, what do you have on your planter system? You got in-furrow and 2x2 plus wide drop?
Just in furrow.
Just in-furrow?
Yeah, and then we come back with nitrogen knifing it
Okay.
Okay.
knee
Yeah.
high.
So Al, do you have enough information on him before he gets a bee crop test to give him any kind of recommendation?
Yeah, good. Yeah. You want me to? Yeah.
Yeah, let's do that. And then David, if you could pull a bee crop and send it off, or maybe did Paul do that or not? I don't remember.
I don't think I don't know. I'd have to go back and ask him.
Yeah,
He's the one that actually did this test for me.
yeah. If not, I'll encourage him to get over there and pull one for you or help you do that and send it off.
Yeah, I can do that.
Okay. You got any other questions that you could think of, David?
Not right now, no.
Okay.
Okay. I'll send those out, Joe. I'll get those over.
Yeah, I think, what was it? Was it January meeting you were on the MAC group, Al? Yeah, I think
Yeah, I was on a couple of your meetings.
okay. Yeah, you watched that, David? Okay.
No, I haven't. I saw the December meeting, but not the January meeting.
Yeah, so Al is on to January. So this will help you understand even more if you watch that January meeting where he was on and talking about all this.
Yeah.
Can you send me the information on the January meeting? Because I never got that.
Okay, yeah, I'll do that. Okay.
Yeah,
Okay.
it was Bo. Got another
Yeah, Bo.
quick question going back on the total nutrient digestion analysis. Nitrogen is still, do you know what they're testing on that to get that number? That, I mean, when you're talking, that, 1,500, 2,000.
Yeah, they're using a real strong acid extraction, and they're using it all the nutrients.
So what is it that is being measured that's, and then
Measuring nitrate, ammonia, and inorganic nitrogen, all three.
the inorganic nitrogen, because that's, I mean, when you compare, I guess you call it the standard soil test, Malik, whatever, is test organic nitrogen.
They don't test organic. Malik doesn't test nitrogen at all. Malik,
okay.
they'll add nitrogen for a cost, like $2 or $3 to add on, and they'll use usually use potassium chloride, or they'll use some kind of extraction. KCl extraction or it's a different measurement. And they're
Okay.
going to give you ammonia and nitrate. They're not going to give you organic nitrogen.
Just a strange number to how large it is and being unavailable. And then, yeah, what is it?
And
Or how
that's
to,
something, isn't it something when you think about standard soil testing that it's
It-
all geared towards selling more nitrogen?
no, it is.
Yeah.
It's a total mindset change when it's seen that number. And I've had people come by and visit and show them that, and it just basically nobody believes it, that it's a true number. So it's kind of, I don't know how to explain it to them. And the only thing is, I mean, when I look at what I've done with very little nitrogen, I call it a nitrogen deficiency program, and it's still producing what I need. And
Right.
so that number triggered me and says, okay, there's something there that the plants are finding, or something the biology is finding, and it's not what we've been told. So that's trying to find out, well, obviously that nutrient digestion test, they're testing something there that's probably adding up to the saying if we need 1 pound of nitrogen per bushel of corn produced, well, that's to me, that when I'm putting on, call it less than 40 pounds every year and producing 260, 280 bushel of corn, it's that part of it where it's coming from.
Your story needs to be plastered on the MAC group's webpage. That's a wonderful story to be telling.
But then,
Yeah.
I did a drastic change from I'd say in 2 years. From 1 year, 3 years ago, I did just a little under 500 acres, 2 different areas. I went with a foliar and tried it, and seen no yield response, negative response, going from 250 pounds applied. So typically I apply 100 pounds of dry urea pre-plant corn. I would side dress 100 pounds of anhydrous ammonia, and then I would fertigate the remainder of my needs with through the water with a 6-to-1 or UN32 thiazole mix.
Yeah.
And I changed from 1 year to the next, and then no change in my yields. I even went to conventional plowed soil, and I had my corn test plots on it for DeKalb and Pioneer. Everybody had 50 different SKUs out there, and I still had 260 to 330 bushel corn with 25 pounds of foliar applied only. And I plowed the ground beforehand. So my tillage practices were horrible. My soil practices were horrible. And I only did I think 4 foliars with 25 pounds, or 5 maybe was on that. And it still was producing. But it showed me the good areas did not change any. My yields were exactly the same. My poor areas, I could see them fall off. That's what it pointed out. My poor, I called my white soils, my poor low biological active soils showed up, and that's it. But on the average, I reduced my inputs by 80%, and my yields didn't drop less than 10%. So still trying to figure out how to show it. And it, like I say, it intrigues me with Kevin watching his yields of breaking that. I call it that 350 bushel barrier, where most farms you can get up to that 300, 350, but trying to crack over that is, you have to have something special going on, in my mind.
Well, what I want to do, what Rick and Lance are doing now is, and I'm going to jump in on this one, is what we're going to give it an efficiency calculation. So let's say you have a soil like I showed you with Eric's there, that has a really high microbial carbon, good microbial story. His efficiency factor is going to be much better than for solubilizing an input, let's say a nitrogen input, than will one that has a soil health calculation of 5. So there's a factor involved. The better the soil health, the better absorption of nutrients.
Mm-hmm.
So that's going to be a big factor we're going to add into our report, so we can show how can we get better efficiency of fertility, I would say digestion, than what we normally have with soils that really have high salts and high tillage. And you're on the right path, Bo. I'm impressed.
No, it doesn't make sense. And when the neighbors around me and all that, I'm going to say they think I'm crazy, probably what I'm doing, and they might not even believe me. And I don't believe it. I wouldn't believe it myself, going back, because 5 years ago, 6 years ago, I was a moron farmer. I was going for high yields. When my corn crop looked the best in the mid-season, everything, then pour the coals to it, add to it, and I started pouring more, and I could not break that I call it the low 300, even
Yeah.
though everything looked great. But then I did have spots that I ignored in different fields, and they broke in the high 300s. And it's placed my soils were poor, my stand was poor, and I did not do anything extra. Just did the standard basic program, and all of a sudden there was yield there. And it took a while to figure out the correlation. Where to me it was the nitrogen that the nitrate nitrogen that I was pouring on with the fertigating it. It's so easy when we're irrigating every day, and to put a tank on and just spoon feed it and trickle feed it. And so that was my path. Was I can spoon feed whatever I want, but reality I was seeing it was taking yield off, where I was seeing a lot of second ears, and then tip back on my corn when I was coming in with that late 50 pounds of nitrogen that I thought I had a 300.
But you had to have it.
There's times I counted on an early stand that I thought I could have 400 bushel corn out there. And so I got to feed this crop in order to save it. And so I come in with another 25-pound shot of nitrogen. It could easily do it in irrigating it in a couple days, 50 pounds, in a week or two. And it tip back and melt away and disappear. And I'd never have it. And it was frustrating. So I swung the pendulum the whole other way and says, screw that. I'm going to go to less is more and try to save myself rich.
There you go. And it worked.
but then the whole deal is the soil health, where that's the whole thing. That's there's no good standard measurement of soil health and what are to release and what we have available. And so that's what I think.
I developed this system to pay for.
No,
I would hope this becomes a standard soil health test, because that's what I hope.
No, I believe it's everybody, farmers and everybody around, is changing their ways, and I think it's going to be the next way that we're going to measure soil by how alive it is, and the biological activity, and score it that way, and not a nutrient digest or total nutrient. I mean, right. I chasing a perfect balanced soil for a while with the manure program, but still trying to get that perfect balanced soil and high nutrient levels, and we could correlate my highest manured fields and nutrient levels with yield on alfalfa hay. That would produce, and it could correlate better. But on corn, it did not match up. It just did not. But alfalfa hay, for some reason, with manure, they match up really well in my soils, and it was an easy button. I could get most of my neighbors would be, call it 7.5 ton alfalfa hay. I could get 8.5 to 10. On mine average. I could beat them by 1 to 2 ton of production every year with a simple manure program, nothing else.
Right.
And it was the easy button with manure. But corn, it takes more. But then alfalfa hay, we weren't tilling the ground. I wasn't doing any other fertility practices.
Yeah, you're letting it.
I front loaded with manure and left it alone, and it provided for me.
Yeah, that's going to be your key. That rotation and letting that last cutting go in to help your corn.
Yes,
I think you're on it.
Yep, and we used to have potatoes in our rotation. We would rent out our ground to neighbors for potatoes, and they would fumigate it. So our farm was getting fumigated once every 5 to 6 years.
Well, I can see why you have low. I can see now why you have low colonies.
So I'm about 5 years in with no fumigation, and I did end up renting some ground out to potatoes again, but the stipulation is no potatoes, because I can get $1,000 an acre rent for potatoes right now, and that's about all I can get on I can't even get that on a wheat crop, in rotation. So it's kind of one of those survival deals. But we're going to we're doing it without fumigation, and so there is going to be some tillage there. But I got to have tillage to get back into the alfalfa rotation anyway. So I'm looking at I call it a 5 to 6 year of reduced to no till with just a strip till. Alfalfa hay, corn, no till, strip till, and then I'll have 1 to 2 years of tillage to get back into the alfalfa hay, where I'm doing peas, wheat, and hay, and then the ground gets a break again. But Kevin Cal gives me hope that he says, yeah, if you build your biology up high enough, you can set it back a year or two with a little bit of tillage and a crop rotation, but you can recoup faster than without the proper technique. So
it's the most soil.
Soil
is such a renewable resource if we just know how to treat it. It really is.
Yeah. So it's kind of one of those, 1 step forward, 2 step back, or I look at it's a 2 step forward, 1 step back, for a couple of years with doing the transition from I call it corn back into alfalfa hay again. So yes, it might be I step back just a little bit, but once I got it in the hay, then it takes off, and then I'll be off to the races. So
A good story. We need to do an
Yeah.
article on him, Joe. We need to
I
have
know it. I know it. I'd love to come out there and visit him. This is a long trip, Bill.
yeah. No, I'm glad to hear, Al, that you've been in this area. It's kind of neat to hear that at least you're
Yeah,
familiar.
I was out there messing around with the corporate ag world.
Yep.
Yeah, and I know exactly where you are. So you got Nutrien and Helena and Simplot. Who else you got there? Wilbur Ellis.
Yep. Wilbur, yeah, Wilbur's been my go-to, but they're imploding, all of them
Yeah,
around
they
us.
are. This is a message they can't quite understand yet.
No, and I have my Wilbur Ellis grower meeting tomorrow and all day for my pesticide credits, and it's interesting to hear. But I mean, I heard one of my friends work at Simplot. He says he's got to cut $1 million in his operating budget in order to sustain. A friend that one of my best friends I grew up with manages the Wilbur Ellis. He says it's 2 of the worst years ever. All the big guys are imploding because they have not changed.
No,
but the problem is that
lost you.
they're preaching it that they want to change and be sustainable, regenerative. Still a standard. I call it large scale. I try to think how to put it. You're going to grow a corn crop, and they'll give you a program farming. They'll give you your whole program of what you need to do on your nutrient application, your herbicides, fungicides, everything.
Surfactants.
Yes, I mean they give you the whole scheme, and there's a lot of guys farming that way, and it works. I'm not going to deny it; it does work, but it's at a cost.
But it's expensive. It works, but it's very expensive.
Yes, but there's no yeah, they're very slow to change, and basically, and then the service. It used to be a lot of service, boots in the field with agronomists. I'm gonna say 10 years ago, 20 years ago. Today, it's gone. I call it corporate style, where they can give you a recommendation for your crop and never step foot in your field, and then they have another guy that's going to do the service work instead of the agronomist coming out and set up a fertilizer tank or do anything and set it for you and stand in the field, or give a fungicide recommendation. It's they pass it on to a third party or another company's doing it.
They don't want to stick their neck out.
No,
They let the product manufacturer do that.
Yes, it used to be full service, and now it's basically just wholesale selling products, and I think it's gonna, what I see around here, it's going to be a change of in the support of ag from those large guys. I think in the next 5 years are going to almost go away, and they're going to go back to the small, I call it ma and pa, the little guys. Personal recommendations, different way of farming, and change.
I'm already seeing it, though. I mean, the whole thing was, when you have products in the form of these dry fertilizers that are so low efficiencies. I mean, from 15%, it's common for MAP and DAP to be 15% efficiency. Potash the same way.
Yep.
Why would you recommend these rates that are so high to the farmer when you can only get efficient use of about 15% of it? Yep. So my whole story is the total soil digestion gives it away.
Yes.
Stop it, guys. You're giving these farmers advice on products they don't need.
Yeah, exactly.
Yep. But when you say, I struggle. I got to find any local agronomist that understands chemistry and interactions of cause and effect of products, that whether it's fertilizer, chemical, insecticides, anything, fungicides. I don't know if I've only know one local guy that has a passion for chemistry that can explain the interaction of any application of a fertilizer or a pesticide would we apply, that understands what's happening with biology. One neighbor guy that's passionate about it, a cherry farmer, and he makes a little bit of his own fertilizer and stuff. But one guy in my area that can explain it. Otherwise, not one agronomist. If I go out there to anybody, and I searched around probably 4 years ago before I got on the MAC group, trying to find somebody in my area to explain and help me explain the unexplainable. And that's what led me to the MAC group. Is even though it's the Midwest and it doesn't match up with my production, it's the mentality and the how they approach things and the decision making. It's not that it's the same approach. Kevin's farm and everybody, all these other guys in the Midwest are different than me, but it's the thought process and how they break down what they do and why they do it in interaction. And it's a blessing to, like say, get the help with Joe and all you guys to explain this.
Well,
and,
we need to be thinking like veterinarians think. We need to look at with the rumen of the gut of that system instead of looking at it through the chemical approach.
I come to understand that the soil health, plant health, and human health and animal health is all identical.
Yeah,
exactly the same.
It is.
And I mean, my whole mindset on my whole personal health and soil health and plant health is all in the last 3 years. It's been flipped upside down, and I'm excited about it. I feel like I have a little bit of control on my destiny now because of trying to understand it. Yet, the more I dig into it, the more I realize I don't understand.
You don't know.
but at the same time, I feel a heck of a lot better feeling that I know more than, say, my neighbor or other people, what they're doing, and look across the fence and see what I'm doing. I feel so much better about my family, my employees, and everybody being around my farm. And I'm not organic. I mean, I'm not saying that, but I'm learning how to reduce my inputs and maximize what my soils can do on their own. And
being a profitable business instead of one that's costing you money.
Yes, no, it was striving for high yields for a while there, and I love that. And then now it's like, no, it's call it, you get humble a little bit, and then you start to realize, that just being sustainable in this business means more than anything.
Right.
And like I say, I go back to this Mac group has been great for me because, like I say, looking at what Kevin can do with his yields and his methods and how he's doing it, and all these other farmers and listen to their stories, and everybody has a unique challenge.
That's right, they do.
West. And it's and you just showed it today that, I mean, two different farmers from between mine and it was the Smiths or whatever that.
Yeah, in Arkansas. Yeah,
totally two different problems or whatever, but similar. I mean, if you look on the basic sample, they look like the same, but totally two different issues to address what's deficient in our system.
Right.
And it's kind of neat to see that it is complicated. But
and he's got a whole different. He's getting, you're getting 8 inches of rain a year. Of course, you're irrigating, but he's getting about probably 40, 60.
Yeah.
And he's growing Bermuda grass hay and trying to make a success of it.
Yep.
Without a lot of in the same situation. I told him, let's get away from all these dry fertilizers. They're actually a boon to your problem.
Yep.
So he's dropped it. He actually went out and sold his spreader and got him a manure spreader.
Yeah. No, that was like with manure, because I have a feedlot that my family bought years ago, and it basically was a dilapidated feedlot that went bankrupt, but that was our golden goose, having that manure where everybody else didn't want anything to do with it. It literally was a big pile of shit, and so we took that feedlot and started spreading that on our ground, and all of a sudden growing hay and corn, producing. We're competitive. We're competing against potato and onion growers in our area growing hay and corn, and it's because and we did not have to buy any potassium and phosphorus. And then we leased the feedlot out, and we were getting paid. I remember in high school, I was running a manure spreader and getting paid up to $250 a ton to haul out a manure out of our own feedlot or the neighbor feedlot and spread on our own ground. They paid us to show up with a truck on the side of the pens and haul the manure out all winter. As long as we could do weekends, we would sit there and haul all we can. Now there's people standing in line, and it costs $15 a ton for raw manure, and you can't get it because it's tied up.
Yeah.
Wow.
So, and it's call it the old mind change mindset.
It is changing. Yes.
But my soils, I think, are showing after call it 20 years of a manure program and call it, I'd say probably no dry fertilizer, virtually no dry fertilizer. I mean, I got some benefits, but it's still not right.
Yeah. Your nutrient levels are beautiful. I love seeing that. That's great stuff.
But my organic matters are low. And
but you're going to build, once you get that carbon story fixed, you'll build those build up.
I would say the last 3 years, I think I'm going to say I'm not quite 0.5% of organic matter build, but I would say if I looked 10 years ago and took my average soil samples, and today, I think I'm 0.5% better. So going from call it 1 to 1.5 to 1.6 to 2.2 is phenomenal. And I think it's one of those, once you get there, it gets easier and easier. The first call it going from 1% to 2% is hard, and it's kind of like making the first million. I think it's the same philosophy in organic matter. building that first 1% additional organic matter is really hard, but once you get there, that ball is rolling. I think it's going to be easier.
I do too.
So
Well, very
Yep.
good, guys. Well, thank you for the call and the time.
Yeah.
And I'll get some
Yeah.
stuff sent out, Joe, to you.
Yeah, okay. And David, did you have anything else before we sign off?
No, but I gotta go before long.
Yeah, I got to
Okay.
roll.
All righty.
all right, thank you
All right.
guys.
Hey, thanks, guys.
Thank you
Thank
all.
Thank you.